In this problem, we need to transform the polar coordinate 4, negative pi over 4 into its corresponding Cartesian coordinate. So let us begin. Since we are given the polar coordinate, so here we have the value of r and theta. So r is 4 units and the value of theta is negative pi over 4 radian. So we'll begin by first considering let the point P. So let the point P be represented by the Cartesian coordinate x, y, and it also corresponds to the polar coordinate O, negative pi over 4. Then we can say that the value of x is going to be equals to r times cosine theta, and the value of y in terms of the polar coordinates will be r times sine theta. So let's replace the value. So r is 4 units and we have cosine of negative pi over 4. Now cosine is an even function, meaning even function means cosine of negative theta that corresponds to positive cosine theta. So cosine of negative pi over 4 is equals to cosine of pi over 4. This gives us 4 times cosine of pi over 4, which is a standard value 1 over square root of 2. So this gives us 2 times square root of 2. And let's now also find out the value of y. The y is equals to 4 times sine negative pi over 4 radian. However, sine is an odd function, meaning if we have sine of negative theta, that corresponds to negative sine theta. So sine of negative pi over 4 is going to become negative sine pi over 4 radian. So we have negative 4 times 1 over square root of 2, and this corresponds to a value negative 2 times square root of 2. So we have successfully found the Cartesian equivalent of the point 4, negative pi over 4. So its Cartesian equivalent is going to be 2 times square root of 2, that's the x coordinate, and the y coordinate is negative 2 times square root of 2.